This problem asks us to divide these two fractions here. Before we do this more complicated example, let's look at a simple example of dividing fractions. Let's say that we have 4/5 divided by 2/3. And when you're dividing by a fraction, it's the same thing as multiplying by that fraction's reciprocal. So this is also equal to 4/5 times 3/2. And then once you flip the fraction and you're multiplying, multiplication is very straightforward. We just go straight across. So 4 times 3 is 12, divided by 5 times 2 is 10. Each of these have a factor of 2 in common, so it becomes 6/5. Now let's apply this principle to our problem. We have this fraction here divided by this fraction, which would be the same thing as the first fraction times the reciprocal of this fraction. So we just need to flip this fraction and multiply it. So we have that y squared plus y minus 20 divided by y minus 3 is multiplied by the reciprocal of this fraction, which is y squared plus y minus 12, all divided by y squared minus 16. And what you can notice is that these three quadratics here are each factorable. So let's try and factor this, and hopefully we can make some cancellations. So let's start with this numerator here on the left fraction. We have two sets of binomials, and we know that their first terms multiplied together to get y, and their last terms multiply to get negative 20. And we need to think which two factors of negative 20 add together to get plus 1. And we know that 4 and 5 make 20. And so if we have a positive 5 and a negative 4, we can get negative 20 for our last term and plus 1 for our y term. So we have plus 5 and minus 4 for that quadratic, divided by y minus 3. And this is multiplied by. Now let's factor the numerator on the right fraction. So we know the first terms multiply to get y squared, so y and y here. And their last terms multiply to get negative 12. So let's think of which factors of negative 12 add together to get plus 1. And we know that 3 and 4 multiply to get 12. And so if we use plus 4 and minus 3, they'd multiply to get negative 12 and would add to get plus 1. So we have plus 4 and minus 3. And then this is divided by y squared minus 16. And notice that 16 is just 4 squared. So we really have a difference of 2 squares. And you can write that as the first term minus the second term before it's squared. So y minus 4 multiplied by the first term plus the second term before it's squared. And now that we've factored everything, we can make some cancellations. So notice that we have y plus 4 here and here. We have a y minus 4 here and here. And we have a y minus 3 here and here. So what we're left with in the end is just this y plus 5. So our answer, when we divide those two fractions, is simply y plus 5.